Hello guys, in this video I'm going to show you how to solve equal subset sum problem using bottom-up approach. In the last video we solved it in using top-down approach, right? With recursive calls. But for bottom-up, we're going to use as always, bottom-up. We're going to use two-dimensional table, right? So what is rows and columns here? So it's pretty obvious that we have set numbers and a target, when a target sum, right? Sum here is 10, but so the target sum here is 5, as we discussed in the last video, right? We want to find subset, one subset that sum up to 5. So the other set will be 5 for sure, right? Okay, so we have two input here, right? So the rows will be our data sets, right? 1, 2, 3, 4. So here I have 1, 2, 3, 4. The columns will be all the values from 0 to half of sum, right? Which is the target sum 5. So at each cell, we want to find the answer for whether we can find a subset that considering our current data set that sum up to, for example, if we are finding value for x, right? It means we're considering array input 1 and 2, whether we can find a subset that sum up to 5, right? Whether we can find a subset that sum up to 1, right? Because we're a column with values 1, right? And we're considering every values from number 2 upward, right? So we're only considering 1 and 2 here, right? So for example here, y, we're considering all the number, right? Whether we can find a subset that sum up to the row value, which is 1, right? Okay, let's try to solve it manually first. So for 0, can we find a subset that sum up to 0 using input of 1? Yes. The subset is just empty, right? It's just nothing. So it's same here. Whatever the input is, we can always have a subset of empty subset that sum up to 0. So here is for the first row, and let's start from top to bottom, left to right, right? So here, using 1, can we find subset that sum up to 1? So as the previous approach, same here, we also have two choices here: either take 1 or either skip 1, right? it obviously that if we couldn't skip one here, right? Because it is the only value, so we can only take one, right? So if I take one, how to say? We're trying to find subset that sum up to 1, right? Which is this value. So if I take 1, then obviously I have a subset that sum up to 1, right? So it's true. So from 2 to 5, if I take 1, right? If I take 1, then I subtract 1 from 2, I have 1 left, right? Here I have 2 left, 3 left, and 4 left, right? So it's obviously that I couldn't find subset that sum up to 3 to 2, 3, 4, 5, right? So it's all 4. So that's the rules for the first row. The first column is all true, right? It's something that we confidently say that is true. And for the first row, we can recognize that only one for the first row. You're only considering the first value, right? So only the row, the column that has the same value adheres as the row here, then the cell is true, otherwise false. So remember it. So later we can fill out our magic, right? So again, for 2, here we starting fill up our table. For this cell, we're considering 1 and 2. Can I find a subset? Can I find a subset that sum up to 1? The subset that sum up to 1, it is, as you can see, if we move one step forward, one step upward, we can find the answer here, right? So a 2, we have 2 choices, right? Either take 2 or either skip 2, right? So if we skip 2, it means we can take the answer from here, which is not considering 2, but still find a subset that sum up to 1, right? So we have 2 choices here, take 2 or skip 2. So either one of the 2 is true, then the value of cell is true, right? So we don't need to count for the case that we take 2, right? We can take the value from the case that we skip 2, which is write the cell above, right? So here again, 2 case, if we skip 2, then of course we cannot find, right? It's false here. So the only possible case is we take 2. So if we take 2, then obviously that I have a obviously that I have a subset, right, that sum up to 2, which is 2 here, right? So it's true. For 3, skip 2, considering 1 and 2, can find subset sum up to 3. If we skip 2, the value is false here. So we're we need to consider the case if we take 2. If I take 2, then I can subtract 2 from 3. So the question now is if I can find a subset that sum up to 3 minus 2 is 1, considering the input in this case only 1, right? Because we take 2 already, not considering it anymore. So yes, I can find 1. The answer is yes here. I can find subset using 1, the sum of the 1, right? So it's true here. So actually the subset is we take both 1 and 2, so the total is 3, right? It's 3 here, equal to 3 here, so true. But for 4, if we skip 2, no, the false here, so we must take 2. If I take 2 here, subtract 2 from 4, right? The problem comes down to whether I can find subset sum up to 2, not using 2 here because we take it using 1 only. No, so false here. Same here, false. If we take 2, then the select 2 from 5, then the total is, the target sum is 3, considering only 1, it's 4, right? So here is 4. So as you can see, for each sub-problem, we're using previously solved problem, right? For example, here we are using the result from the cell that we've already calculated. For 3, yes, I don't need to, I just need to care about if I don't take, I have 2 choices, right? So if I don't take 3, I can take the value from above, right? 2. Here, true, true, true. No, wait a minute. Here is 4, so I need to take 3. If I take 3, then I subtract 3 from the current target sum. So the new target sum is 1, not considering 3. So it's true. False. 5 minus 3 is 2. 2, not considering 3 is 2 here. So it's true. Okay. So probably we don't need to calculate everything here because we only need to know that here this cell means we've found a subset from 1 to 3 to sum up to 5. That's exactly what we need, right? So probably we don't need to calculate everything here, right? So enough for explanations. Let's try to code it out. So we need 2-dimensional table, right? So we need rows and columns. The number of rows here is, we need 4 rows, right? Same as the number of inputs here. So nums.length columns, total of columns is it depends on the sum, right? I need to calculate the sum first. So sum is, how do you reduce a and b, return a plus b. Okay, so we can early exit, early return if the sum is a odd number, is what we choose is 1, then returns false. I cannot partition it, right? So okay, so the rows here, the column is columns, no, the sum divided by 2 with half of sum with target sum here, and plus 1 for the 0 value, right? Okay, I'm gonna use a utility function like generate magic. Generate magic taking columns and rows and columns, and generate a 2D. A DP stands for dynamic programming. It's a 2-dimensional table. Generate magic rows and columns. This return a array rows. Okay, this will fill with no, false, for example. No, it's no, and I will map each value with another array, right? So by doing this, we have a 2-dimensional tables. For each row, I will map into a new array of total columns. Okay, this will further fill with what here? Fill with false. Let's say false. Okay, but probably I want to initialize our, yeah, probably we can do it later here. Okay, let's check our function here. Shared magic 3 and 3. Okay, this works fine. 4 and 3, 4 row and 3 column. Okay, works. Okay, I'm initialize value here. The first row will be always, the first column will be always true, right? As we discussed earlier. for that row of dp. So row 0 is equal to 2. Okay, for each row we're going to reassign the first value of each row to 2. Also for the first row also. For the first row, let's call of first row is dp 0. I think 0 is here is the first row, right? So for so so we're gonna reassign if the value of number here is equal to the current column. How do I get access to current? Alright, probably I will use this one. So for let I call equal to 0, call let call plus plus. Okay, the first number we're considering here is if let's say if nums first number is 0, right? Assuming 0, a equal to column wait a minute. For example, sum is 10, then have sum is 5, right? When the sum run from 0 to 5, it means we have 6 columns. Okay, here are the total columns. Okay, if the first number is equal to call, then it means I'm gonna assign dp at what? dp of 0, the value of call, right? This we're going to show for the first, want to initialize the first rows and first column so that we can start filling our table using the first row and the first column, right? Let's double check it again. Okay, we start from col 0 to col. Okay, col plus plus. So if the current column is equal to first value, then I'm going to fill up, I'm going to reassign true to first row value column. Okay, so let's start to fill our table. I'm going to start from let row equal to 0, row less than rows, row plus plus. Let column equal to 0, columns, then calls, call plus plus. Okay. Oh, I'm gonna start from row 1 and column 1. Alright. So at each cell, we first consider the case of skipping current number, right? So what is current number? Current number is numbers at row minus 1. For example, here, if it's a cell, we are at row 0, right? So the number is no, the row itself. Sorry. Okay, the row. The current number is the current number we can access by the row index, right? For example, here the row index is 1. So we access 1 from the arrays, right? So current number we can skip it or take it, right? So firstly I can skip it first, right? I can check the value one cell above, right above it, which is current row minus 1. Current row minus 1, and column is the same, right? So I'm gonna check if I skip it. So if the value at current row minus 1 and column the same, if it is true, let's make it clear here. If it's true, I can just I will be sure that the current cell is true as well, right? So probably I don't need to check the other case, so I just continue if this is true. So otherwise, if I come here, then it means I'm gonna take it, right? I'm gonna take the current number. So I will only take the current number if the target sum, which is a column, right? Column value, column is greater than or equal to the current number, then I'm gonna take it, right? So the problem now comes down to I need to find the value somewhere above, right? So the row and column will, the current cell will be not considering the current number because I took it, right? So not considering it means row -1, and columns target now is column, current column minus the current number, right? We find a cell value from a cell that we've already calculated, right? So alright, only so that we can make sure this is greater than or equal to 0, right? Okay, I think that's it. Okay, so after we exit the loop, we fill up everything, right? So as long as we can find one true value in the last column, means we can find, it means we can partition, right, it into two subsets with equal sum, right? So here I can return our DP. I want to use the last columns is called -1, right? Wait a minute. No. I'm gonna return. So for every column, right? Come on. I can check it here. 0. And from 1. DP sum, right? If there's a row, DP here is a array sum. Okay. The condition I want to check here is the last value of the row, which is row calls -1. Okay. Not sure if this is correct. Let's see. M. So M dot we have 4 rows, 3 columns, right? 3 -1. It is no. But if I change something like but row 1 column 2 is equal to true. Okay, run it again. Hit true. Right, correct. So let's run the test. Okay, it's passed. Okay, that's pretty much it about equal subset sum using bottom-up approach with two-dimensional table. Hope you like it. So thanks for watching. See you in the next video.